For those of you that don't know me, I'm Scott Raffle. I'm a Knowledge Exchange Manager for Niab at East Malling. And the purpose of the event today really is to bring you up to date with a lot of research that's going on, both through Niab at our East Malling site and also through some associated programs, and some PhD students will also be adding to the content this morning. We're very pleased to have over 200 delegates have registered for today. I can see the numbers are rapidly rising. So I'm going to just run through a few issues about housekeeping and how the event will work today. So first of all, we have muted you, and hopefully you will not be heard. Hopefully just the speaker will be heard this morning. We've hopefully switched your cameras off too, but we can't always guarantee that. We have had difficulties in the past. So can I ask everybody that's listening into this and watching it to please just double check that your camera is switched off. It can sometimes be embarrassing for you, and it can be embarrassing for us if we can see what's going on in delegates' offices and homes. So please just double check that you have switched your camera off this morning. You've possibly just been made aware that this event is being recorded, so that those that can't attend today will be able to view at a later date, and it will be uploaded on our website. There will be an opportunity to ask questions, and that can be done through the chat facility. We do ask people not to shout the questions out. It's much easier when we've got this number of people on a virtual system to actually just send your questions through the chat facility on the Zoom website. Most of our talks, we hope, will stick to time, but my job as chair of today will be to keep us to time. So I will be ensuring that if you aren't able to listen to all of the presentations when you do arrive, you will be on time to hear what's being said. So once the recording is done, we will upload that to the Niab website at www.niab.com. And I think if you look at the events section, you will find previous presentations and events available there. You can also go onto the Niab Fruit page of the Niab website, and it should also be available there. Right, one very important matter, which is basis points, because I know a lot of you join in with the expectation that you will be receiving basis points. I'm pleased to say we have been allocated 4 points for this event. That's the basis reference number at the top in bold. You'll see there's 2 points for crop protection, 1 for plant nutrition, and 1 for integrated pest management, totaling 4. We have a QR code there. So if you want to register, you can do online. We've set it up as an online registration. So if you zap that QR code, that will take your phone through directly to the registration form online. If you don't have time to do that now, Phoebe Carter, who's helping to run this Zoom call today, Phoebe has posted a link to this online registration form in the chat facility. So at any point today, you can go into chat, and if you go to the top of the chat, you will find a link to the basis registration points. You will need to add in your full name, your basis account number, and your postcode. Now, similarly, for those of you that are interested in Noroso points, again, there will be 4 points available for that, and there's the code at the top. You can link to that online form using that QR code. Or again, Phoebe has posted, or will be posting, the link for the online registration in the chat facility in this call. Again, you'll be asked to put your full name, your Noroso account number, and your postcode in. So just a little bit about today and some of the presentations. We've got a full agenda for you. We've got a lot of information, new developments, results from research projects that we want to share with you. We have 3 sessions in total, first starting just in a couple of minutes' time at 9:30. Session 1 is a mix, really. We're going to kick off with a little bit about growing Kent and Medway, which is an innovation cluster based in the Kent and Medway region. Many of you have heard of Growing Kent Medway. It has its own dedicated website. We're going to tell you a little bit more about Growing Kent and Medway and what the Food Accelerator programme has been achieving. And my colleagues from Growing Kent Medway will take you through that. We'll have Philip Doubleday, who's been a recipient of the Food Accelerator programme and beneficiary of that. He'll tell us a little bit about it. And then Lauren Colagiovanni will tell you a little bit about some new funding opportunities that are available. Then we've got Charles Whitfield, who's been working on, or is starting work with a consortium on developing digital crop management technology, which will potentially benefit the soft fruit industry down the line. And then we have Papp-Rupar talking about coir recycling. Mark Else, who's known to lots of you from previous events like this, Mark will be talking about his ongoing work at the Wet Centre and a new project to optimize strawberry yield potential for total controlled environment agriculture systems. And then Carlota Gonzalez-Noguer will talk about a project that's been going on for the last 2 years on matching nitrogen supply to demand in raspberry. Just briefly, we have session 2 will begin at 11 o'clock. We'll have a break at 10:45, and then we'll move into session 2, where we've got both disease presentations, soft fruit diseases, as well as some breeding and new variety discussion. And then session 3 after lunch will begin at 1 o'clock. We'll break at about 12:15 for lunch, and then we'll restart at 1 o'clock. And then we have a lot of presentations, as you can see there, on the various different pest control projects that are going on, both through Niab and through some of our PhD students. So I think that pretty much summarizes things. If you have any questions, please do use the chat facility, as I mentioned earlier, and do take the opportunity as the event proceeds to register yourself for BASIS and Neuroso points. So I'm now going to invite at this point our first speaker, and that is Jamilla Mohammed, who's a colleague of mine through the Growing Kent Medway team working for Niab based at East Malling. So I'm going to stop sharing my presentation here. And I'm hoping that Jamilla is available. I can see her.
Yes, good morning.
Good morning, Jamilla. Now, if you'd like to share your presentation with us.
Yeah.
So just to, while Jamilla's doing that, let me just introduce you. Jamilla Mohammed is an MDS trainee, Management Development Services, who is working with the Growing Kent and Medway team at Niab at the moment, helping to support us in lots of ways, particularly with our social media and our website and pretty much all things at Growing Kent and Medway. And Jamilla is with us for a period of 6 months, and she's doing a fantastic job. Jamilla is going to tell us a little bit more about Growing Kent Medway and about the Food Accelerator programme. So the floor is yours, Jamilla.
Perfect. Thank you, Scott. Can I just double check you can all see my screen? Okay.
We can see it perfectly, and we can hear you perfectly and see you as well. So all is working well. Thank you.
Thank you, Scott. Well, good morning, everyone. So Growing Kent and Medway is a research, innovation and enterprise cluster. Scott did do a good introduction there. Just a little bit more about our partners. So we have 3 main partners, Niab, the University of Kent and the University of Greenwich, and we are supported by UK Research and Innovation. So just before we jump in, just a little bit about myself. So as Scott mentioned, I am an MDS graduate. They are a management development service program. They offer various schemes, and it's trying to encourage young people and new professionals to get into the horticultural and agricultural industry. As you can see, that's myself enjoying the National Fruit Show. So just a little bit more about our aims at Growing Kent and Medway. So we invest in innovative ideas within the food and drink sector around Kent and Medway. However, very exciting, we have recently expanded to the whole of the UK. So that's something that is new for Growing Kent and Medway. We support horticultural and plant-based businesses of any size, from growers of fresh fruit and veg to food processors to people who are engineers and involved in the robotics side of agriculture. And we help to create a business network where we bring different people within the industry to work together to stimulate innovation and investment within the industry. And we also offer grant funding, which one of my colleagues will speak to you later about that. So I'm here to talk to you a little bit about the Food Accelerator programme. It is one element of the Growing Kent and Medway program. So the aim of this is to transform the our food and drink idea into a successful commercial reality. We've had numerous cohorts now, and here are just two products that were supported through the program. So we have the Nashi Gold, which is a pear juice. It's meant to cure all hangovers apparently, and a Dockyard Jam factory. Strawberry jam. She also has a range of other products. So just a little bit about the program. So on your screen, you can see at the bottom just kind of a timeline of how an idea can transform into a product on the shelf. So it is a 4 month program and it's open to any small to medium enterprise. It can be anything from just an idea to someone who may have a bit of an established business. We offer technical, business, and financial support through various masterclasses, in-person workshops, and we also offer a mentoring scheme. And you also have the chance to work with some of our technology hubs at our partners to get expert guidance and advice about your product. So here's just a little bit more about how it works. So a person will come to us with an initial idea and we will offer an initial assessment just to see if the idea is feasible. And then we'll create a business model. Again, you'll be working with professionals from the Business School of the University of Kent. And then we get onto the exciting part, which is the validation and prototyping, which Philip will share about his journey. And that is working with our Green Tech Hub or the research facilities. And that could be from testing the nutritional content in a product to how to scale it up, how to package it more sustainably. And then the final bit is kind of pitching it to the market and seeking funding. Now, there's opportunity for that throughout the whole of the 4 months throughout our masterclasses, where you do get expert advice in the industry of where to seek that funding. So I've already touched a little bit on this, but just another recap of who it's for. So it is for startups or established small to medium businesses. It does have to be a plant-based product or a plant-based process, and it does need to address some kind of relevant customer health and environmental factors. So that could be something to do with sustainability, making a product more nutritional. And the most exciting thing is now anywhere in the UK, but you do have to have the ability to access one of our partners. Here's just some lovely pictures from our previous cohort. So in the bottom left, that's us visiting one of the factories. And in the top picture in the middle, the lady stood in the middle without not holding a certificate. That's Valerie. She's actually the person who runs the program, and I stepped in today to introduce the Food Accelerator program on this webinar. So she usually is the one who runs this. Here's just some of our other amazing products. I do have to point out the chocolate sourdough at the bottom. Honestly, so good. It's so nice. So you can really see the range of products that we support. And if you do have any questions, please feel free to send Valerie an email and connect with us across all our social media. But thank you today. And if there's any questions, I'd be more than happy to answer them.
Thank you, Jamilla. We haven't got any questions coming through at the moment, but they may arrive. So stay with us and we can put those to you. I think we'll move on. I should have said earlier that this particular presentation is a tripartite presentation. And so we have 3 speakers. And so that was the original input from Jamilla. I'd now like to invite and welcome Philip Doubleday to join us. And we've got Philip with us today primarily because Philip is a recipient, if you like, or a beneficiary of the Food Accelerator program. And he's going to share with us his experiences of that and tell us a little bit more about what he has been doing with a new drink product that he's involved with. So good morning, Philip.
Morning, Scott. Morning, everybody.
Perfect. We can see you and we can hear you. If you'd like to...
Can you see my screen all right?
We can. And if you click on slideshow, that's great. Thank you.
All right, let's get into it. So, morning, everyone. To introduce myself, I'm Philip Doubleday. I come from a family of farmers both here in North Kent and in São Paulo State, Brazil. But I'm here to talk to you about my experience as a Kentish fruit grower turned winemaker, and how the Growing Kent and Medway Food Accelerator is helping me along my journey. So I've been involved with cherries for a couple of decades in a family business that's been at it for about 100 years in a region that's been doing it many hundreds of years. And that's because we've been gifted with the climate and soils to be able to do it exceptionally well. However, I'm not here to learn about cherries per se, rather than to talk about what we're doing with them and how the Growing Kent and Medway Food Accelerator is helping me. So as you can see, we're making a Morello cherry wine. And to give you a brief history, my grandparents had 4 Morello cherry trees in their garden from which they'd make a few bottles every year of fortified wine they called cherry brandy to give away to family and friends. Then one year I said, "Granny, you've got to show me how you do it." And she was 97 and she said, "Okay." So she wasn't very happy when I picked all the fruit from her trees, and less still with the overflowing fermenting jars spilling wine onto her dining room floors. However, she was very pleased with the results, and actually everyone was, and they kept on asking if they could buy some. It's really quite delicious. To give you an idea, it's kind of like a cherry port wine. So believing in the opportunity we had, we decided to have a go of it. My brothers and my father and I aimed to scale up and planted an orchard, bought some tanks, and got local rural development funding to help build a winery for them. So why the Food Accelerator? For me, when I was first told of the Food Accelerator, the word accelerator really caught my attention, as that's just what I felt we needed after years of development, yet not actually formally launched and in the market. So after doing the groundwork, we now needed acceleration for the business to take flight. We also fit the bill for being an innovative product. So growing Morello cherries is very rare nowadays in this country, and planting and growing an orchard for the specific purpose of winemaking is quite a unique proposition. As growers, we have skills in growing quality produce, however, really lack knowledge and experience in branding and marketing, along with all the other things you have to think about setting up a business from scratch. And this is where the Food Accelerator really helps, to help bring you up to speed with lots of these important areas that often get overlooked or you're just completely ignorant about. There's lots of challenges in starting a new business, not least it can be a very lonely endeavor, just like being a farmer sometimes. So it's very reassuring to be part of a community of diverse and like-minded entrepreneurs, also taking the risk of starting a new business. And my experience so far has been very positive, which is why I'm here to tell you about it. Officially, the program runs for just a few months, 4 months, as Jamilla just mentioned. However, I've been in it for nearly a year, and I don't see an end to the opportunities it's bringing to keep learning and to participate in the network of producers. The in-person workshops have been really valuable, especially from the point of view of thinking about our branding and messaging, and some of the helpful lecture seminars or webinars have included PR and marketing strategy. How to fix your website was an excellent one. The cost of setting up a food and drinks business, as well as a lecture on HACCP, which is an essential part of any food manufacturing business. And you don't have to be on the Food Accelerator for those webinars. You can access them for free, simply being a member of Growing Kent and Medway and going to their events page and seeing what's on. I've also had the opportunity to speak with technical experts, and most recently have been using resources at the University of Greenwich to discover what yeasts are at work in our wild fermentation, which amounted to 7 different yeasts, if that's good or bad. I'm also looking into opportunities to make something of our waste and byproducts, and I'm going to take up the opportunity to have a mentor in the new year, which I'm very excited about and I think I could really benefit from. Yeah, this last slide is the inside of a tank after being emptied. I think it's quite beautiful, and it means we're at the end of my little bit. There's lots more I could say, but that's all we have time for at the moment. And I just want to say thank you all for your attention, and a huge thank you to all those involved in Growing Kent and Medway for all your help and in making this program really fantastic.
Thank you so much, Philip, for that upbeat and enthusiastic sharing of what you've experienced with the Food Accelerator program. We're not getting any specific questions about that, but I think you've done yourself justice there, and hopefully the Food Accelerator program. We're going to move straight on into Lauren Colagiovanni, who is the third and final presenter from Growing Kent and Medway. because Lauren has got a little bit of information to share about some new funding opportunities. And Lauren, we can see your presentation now. Can you unmute and share your video so we can see you?
You should be able to see me now and hear me. Is that all right?
Perfect. That's wonderful. Thank you very much indeed.
Good morning, everybody. As Scott mentioned, I'm Lauren Colagiovanni, so I also work with Jamilla at Growing Kent and Medway. And I'm just here to spend a couple of minutes telling you about some of the grant opportunities that we have open that Jamilla mentioned that we fund as well, which we hope will be of interest. And I don't know why that's playing again, apologies. So the first funding stream that we want to let you know about is our business innovation vouchers. So this is an opportunity to work with one of 3 research organisations in the Kent and Medway region. So that could be Niab, University of Greenwich, or University of Kent. And these vouchers essentially give you 50% of your research costs. So your project can be sized between £20,000 and £60,000, and we'll provide 50% of that cost. And the money goes towards the research organisation. You would need to provide 50% of that, but that can be an in-kind contribution or cash. So your project can't be an off-the-shelf solution. It has to be innovative, and it has to address sustainability in some way. So that could be reducing carbon emissions, looking at your resource use. It could be about reducing waste or food waste within your production, looking at sustainable packaging. And this is our second round of these innovation vouchers. And I just wanted to highlight a couple of successful soft fruit projects that we funded in our first round. So Sharpak, who are a packaging company, are working with the University of Kent to develop a novel soaker pad for raspberry punnets. And Edward Vincent are working with the University of Greenwich, and they're looking at selecting breeding materials for raspberries to improve their texture and to extend shelf life and reduce food waste. So there's more information on our website, and I'll pop a link in the chat. But essentially, if you've got an idea about what you would like to do with these vouchers, all you need to do is fill in a really short expression of interest form, and literally just to tell us a little bit about your business and what projects you might want to work with the university, with the research organisation on. We'll then put you in touch with one of our team who will have a chat to you about your idea. And if you haven't got a research partner in mind, they will match you with someone that they think could really benefit your project and your research. You might be inspired by some of the research that you hear presented today. So it could be an opportunity to work with some of the researchers that you hear present today throughout the conference. And at that point, if you're happy, you still want to proceed, and we think your project and idea is in scope, then we'll send you a full application form. So you'd need to let us know about your idea by the 24th of January with that expression of interest form. And our second round of funding that is currently available as well is a larger grant for a prototyping and demonstrator fund. So these are worth between £50,000 and £150,000, and it's about developing, kind of testing and bringing to market an innovative technology or process. So in your application, you must have a detailed plan to commercialise your idea, and you must be able to demonstrate that in a real world setting for at least a 2-week period. So for both of these grant opportunities or funding opportunities, you can be based anywhere in the UK this time. With this prototyping fund, you will need to collaborate with somebody in the Kent and Medway region, whether that's one of the 3 research organisations or Canterbury Christchurch University or a commercial business. So applications for that close on the 24th of January, and there's more details again on our website, and I'll pop the link in the chat. And that's me.
Wonderful. Thank you so much, Lauren. I just wanted to add, really, we must move on because there's not a lot of time, but just want to add, Growing Kent Medway is an amazing programme of work. We've all complained many times over the years that we don't get enough funding for the industry to develop things, develop new ideas, to build up new working relationships. Growing Kent Medway does it all. So if you're not fully acquainted with Growing Kent Medway, do please go on the website, and Lauren and Jamilla work tirelessly trying to maintain that and provide all the latest information. If you don't look, you might not know what you're missing out on. So please do use the facility and tap into us at Growing Kent Medway. Lauren, Jamilla and Philip, thank you so much indeed for sharing all of that information with us. And I know you've got to scoot off to do other things, but thank you for your time this morning. Okay, so we're going to move on, and our next speaker is Charles Whitfield, who works in the Pest and Pathogen Ecology team at Niab at East Malling. Charles has done a huge amount of work in recent years on technology to support pest and disease control. Charles is working on a new project, or has just started working on a new project, which is developing technology to identify plant stress, pest and disease programs long before we, as agronomists or growers, can ever spot it. Now, the work, as I understand, is primarily on protected crops, but I wanted Charles to share this information with you because I think it's something that has potential for the soft fruit industry in the future. Good morning, Charles. Are you with us?
Yeah, good morning, Scott.
Yeah,
You can you see and hear me?
We can hear and see you. If you can share your presentation,
yep,
that would be great. Can I just say, while Charles is doing that, we are hearing some people in the background. So when you join, if you have just joined us, please do make sure you're muted, and also do turn your video off. We can see one or two people. If your video camera is on, that's perfect. Charles, the floor is yours.
So hopefully everyone can see the shared screen. If you just let me know, Scott.
Yeah, that's perfect. All
perfect. Okay, fantastic. Right, I shall crack on. So yeah, thanks for the intro, Scott. That's really nice. What I'm going to talk about today is developing digital crop management technology, or digital agronomy services, to put it another way. My name is Charles Whitfield. I work at Niab East Malling. And some of the content from these slides has also been provided by Charles Vase at Photonics. So his name is up here as well. So first of all, why do we need new tools, new digital agronomy tools to support growers and agronomists? Well, firstly, it's because the pesticide code of practice, which I'm sure we're all very familiar with, and if you're not, you can find it on the DEFRA and HSE websites. It states that only apply PPPs if they're needed, and you need to consider appropriate control methods as soon as a pest or disease is identified. So the sooner we can spot issues, then the better. And it also states that we need to minimize the use of pesticides and use alternative methods of control, such as cultural methods and biocontrol where possible. Secondly, the number of PPPs available for use and the number of times that they can be applied in a season has been declining due to regulation and various other reasons. And also actually detecting the initial early stages of arrival of pests and diseases into the crop is a challenging and difficult thing to do and very time consuming. And of course, the best way to get effectiveness out of any PPP that's applied is to get that application in at exactly the right time. So ultimately, the earlier we know about issues affecting the crop and where they are occurring, the better. So our digital crop management project, it started earlier this year, and it involves Photonics, who are leading the project, Fargrow, and several commercial growers. And the project aims to develop new digital tools for agronomists and growers. So the current project, as Scott said, is focusing on the protected edibles sector, but the products and services that we're developing in this will be readily transferable to other sectors, including the soft fruit sector. And the objectives of the project are, first of all, to develop portable remote sensing hardware that's suitable for use on farms. So this will be a device that can be held or attached to a human crop scout or agronomist, or could be mounted onto a trolley moving through the crop, or a robotics platform. We'll develop analytics to interpret that captured data from the crop, and then use that to detect, in an automated and mapped way, detect plant stresses occurring throughout the crop. The data will then be passed to an agronomy company who will develop models to predict the causal agent of whatever the cause of the stress in the crop. And the results from this will be integrated with farm management software and digital agronomy services. So the ultimate aim, or the overall aim of the project, is to develop an automated and real-time crop scouting service for growers and agronomists. So how do we do it? Well, the first steps are using Photonics's benchtop imaging system, which you can see an image of or a photo of in the top right-hand corner. So this system is a bit like a hyperspectral imaging camera, and it captures spectral reflectance of the crop tissues across the UV, visible, and near-infrared spectrum. It's 3D imaging with a very high resolution, and it is combined with machine vision to predict the stress, or detect the stress that's occurring in those tissues. And the crucial thing here is that the detection will be before human eye can normally detect those issues. So the data from that is then transferred to the agronomy provider, Fargrow, within this project, to determine the pest or disease or other abiotic stress using their own in-house risk models. And then that information is then pinged back to the grower or agronomist to provide control strategy advice or suggest other products to control the issue. And of course, all that information that's coming back includes location of where those issues are within the crop. So in our project, we are focusing on powdery mildew as one of our targets. As I said, in the protected edible sector, but of course, there are lots of other species that cause powdery mildew in many soft fruit crops, including strawberry. So powdery mildew is a good candidate for this kind of technology due to the amount of inputs that's required to control it throughout the season, and the very high risk to yield if the controls fail or if the controls are applied too late. So the very early initial stages of infection of powdery mildew are also very difficult or perhaps impossible to detect by human eye, making it a good candidate for remote sensing. So although our project is focusing in the protected edible sector, Photonics and others have done work in a previous project funded by Innovate UK and the TFP programme, in a project called First Fleet, led by Saga Robotics. I think many of you may know quite a bit about that project already. So it included the University of Lincoln, Bury Gardens, and of course Photonics, and also Niab were involved in the project as well. So the objectives of that project were to, first of all, create a training data set using Photonics's benchtop imaging system in a controlled environment, and then create AI models, artificial intelligence models, using the digital twin data to predict what the causal agent of the stresses are that are detected, and then deploy that those capabilities in a commercial onboard Saga Robotics's robotic platform. So a little bit of results from that previous project. So Niab, first of all, Niab's role in the project was to provide a spectral library of powdery mildew infected strawberry material. And then Photonics used that data to train some machine learning models. So they used a support vector machine supervised learning model, which was capable of accurately predicting the presence of powdery mildew infection before symptoms were visible to the human eye. And that was that worked both on individual leaves, but also on whole plants. So the accuracy of that prediction was between 75 and 85%, which is pretty good. But there was also some false positives. So some of the control material that didn't have powdery mildew infection also was deemed to have it, even though it was in fact clean. So there's some work to be done there on improving the accuracy of the system. So these are some of the examples of the crop morphological features and the plant compounds that Photonics' system can detect and also map. So we've got leaf area and angle, leaf thickness, canopy height and flower counts. And then in terms of plant compounds, chlorophyll is detectable, anthocyanins, carotenoids, phaeophytin, and fruit stage can be estimated as well. They can also detect, they've also got prediction models to look at or predict vigor, senescence, tissue damage from pests and diseases, and water content. So the animation that you can see running on the right-hand side of the screen there, that is water stress in a strawberry crop in 2 polytunnels. So this is Photonics' portable imaging system, an earlier version of it mounted onto the Saga robot, running through the strawberry polytunnels, detecting water stress over time. So the lighter pixels that you can see indicate water stress through lack of water, which can be used to highlight issues within the crop. So what are the potential benefits of using digital agronomy services? Well, I think primarily the first thing is it's earlier and extensive detection of issues. So the whole crop can be surveyed, and detection of any issues can be earlier than would normally be possible by human eyes alone. And of course, using things like UV treatments that can now be focused in areas that are deemed as high risk within the crop. And biopesticides such as AQ10 are more effective when they're applied before an outbreak has taken hold within the crop. I think the other major benefit is that we can lower PPP inputs overall using targeted or variable rate application based on the detected disease risk maps, and also bring the disease or the pest under control before it's had a chance to disperse throughout the crop. So this project is our new project has only really just started, so there's not much more I can say about that yet. And if anyone's got any questions on the work that we plan to do or the work that's already been done in a previous project, I'll be happy to answer them here, or you can email me directly. All that remains to say is thanks for listening, and thank you to all the people involved in our new project. And thanks, Scott, for the invitation to come and speak today.
Not at all. Thank you so much, Charles. Just a quick question from me. This all sounds very exciting for the future, and hopefully it won't be too long before we can utilize some of this technology. In terms of the hardware that's required for this, how easy is that going to be to move around a glasshouse or a polytunnel?
So because we're working in the protected edible sector, and I'm sure many of you know, there's some very strict hygiene rules on entering things like tomato glass houses. The portable device that's being developed will be, well, first of all, very portable. The idea is that it's non-intrusive, so that a human operator could have it attached to them without the device getting in their way. So it's it won't need someone to operate it. It will be fully automatic. It's just scanning the crop as the human walks through. Or it can be mounted onto a trolley, or, as I said, onto a robotics platform. So it's both very portable, and it will be designed so that it is can be cleaned thoroughly to limit or absolutely reduce any risk of contamination by moving it from one place to another place.
Okay, thank you. And one other question that's just come in, a very quick one, although I suspect you'll not be able to answer this. Have you got any knowledge of how this type of thing would be charged for, should it come to fruition? Yeah, so I can answer it very briefly. So a key component of this project is to develop this service, or to develop the device, the hardware side of it, as a very low-cost device. That's one of the technical challenges we've got. And then the service will be as an agronomy service on a price per hectare. I think that is that's what's being discussed at the moment. But obviously we're at the start of the project, and there's a lot of discussion yet on the commercialization. I'd suggest you speak to Photonics and Fargrow to get more details on that. Okay, Charles, thank you. It's just gone 10 o'clock. Thank you so much for your time. If you can just hang around to the end of this session, sure. Should there be any further questions come in, just keep an eye on the chat facility. Thank you, Charles. And yes, as just a reminder there, if you have just joined us, if you do have questions for any of our speakers, do place them in the chat box that you'll find on the Zoom facility. So we'll move on now to our next speaker, who's Matt Papp-Rupar, one of my pathology colleagues at Niab at East Malling. And Matt is known to most of you, I think, both from previous events and at events such as East Kent Fruit Society. And back in the summer, he gave a short presentation about coir and coir recycling, and that work continues, and Matt continues to be involved with it. And he's kindly agreed to share some of his most recent experiences and developments with us this morning. Charles, if you can remember to switch your video off, that would be great. And I'd invite Matt to join us. We've got your presentation, Matt. We're just waiting to see you.
Oh, you can't see me.
We can now. We can.
Oh, very good.
Perfect.
I just have to speak up. Good morning, everybody. So yeah, I decided I'm going to do a quick sort of overview of what we've done to this summer, and then a preliminary results from this summer, just to keep everybody up to date. So we're going to whiz through a first couple of slides, because you've probably some or majority have seen them already, and we're going to go a bit slower at the end. So ask me any questions at the end if I'm too fast at the beginning. So let's go. Let's try to go. There we go. So the challenge that we have with the coir is that most of the strawberry and raspberry as well is actually produced in coir due to disease pressure in soil, because we don't have any soil sterilants anymore. And it's actually easier to manage. So you can get higher yields, higher quality, and most important, more consistency within and between different fields. And it's much more sustainable than peat media, which is great because it's a side product of a coconut production. But it's becoming limited in supply and increasing in demand worldwide. Many more countries are now banning soil sterilants, which means that many more sectors, not just UK's softfruit sector, are going into the coir fiber media use. And the supply chain is a little bit strained, or it has been very, very strained under COVID, which means that the price is increasing. And actually, supply chain is quite energy inefficient, or let's say carbon inefficient. So we have to ship the coir all the way from East Asia, and most of this coir is then just dumped in the field after 1 year of use or one cropping season. And that's mainly because there is a fear of disease build up, weeds build up, yield decline for unknown reasons, and because of the changes they have to do to agronomy that no one really understands just yet how to do in the recycled material. So we have two sort of separate objectives. One is, can you just replant in the same bags with some sort of amendments or directly? And the other is, can you remove bags, recycle that coir that's in the bag, and then put it in new bags or troughs or another system that the recycled coir can be used? And it's been done by it's been funded by several different people. So you see a lot of different logos here who contribute to different bits. And quick results for replanting, so pulling plants out, putting new plug in the same bag. We have here June bearer from 2019. Disregard here the biochar treatments. All you need to do here, to notice here, is that between red, green, and blue, there is no significant differences in yield decline or in Brix values. So when you have clean bags, and I repeat, clean, without disease and any other massive problems, then June bearer looks like will tolerate direct replanting, which is good. Everbearer, however, had yield decline. So here it is slightly different. You have years at the bottom. Actually, I'm going to try to pointer option, laser pointer. There you go. You're going to see a little bit better what I'm talking about. So here you have a year of coir. So this is virgin. This has been already used 3 times before we planted. And we used some biochars to try to mitigate the yield decline, which did not work. But the main take-home message is that you have about 6%, 6 to 7% year-on-year yield decline in the everbearer, while the Brix levels stay pretty much the same. So this is not great, because a lot of you growing everbearers. So to conclude this bit, again, if there is no massive amount of disease or other problems that you had in the coir, then June bearer would be happy to be replanted, at least for a year or two, maybe not more. But with Everbearer, we have work to do. And with Everbearer, if you save on not buying new coir, this may or may not be offset by the yield decline. In our experiment, it probably wouldn't be, but if you have any higher than 5% yield decline, you might lose that reduction of cost that you had by reusing coir. So then, why don't we recycle it? Well, it's actually a lot of things that needs to be taken care of when you think about recycling. So the coir physically decomposes while the plants are growing in it. You get chemical imbalances building up. So you're building up salts, you're changing pH and other things. And then you have biological contamination that can happen. So you can have pests building up, you have diseases building up, you have weeds building up that all need management, extra management. So how we are recycling at the moment, this I shouldn't say us, this is all done by Overland. So they've decided to have a low labor automated removal of the bags from the tunnels, to have the system that basically takes operator almost out of the equation. And they remove the plants from the bags, separate plastic and separate roots, and they end up with a pretty much clean coir, which then they compost, sterilize, mix with other things, and then reuse in either a bag or a trough. So that's the process. If you want any more details, I'll point you to Overland for that. But we first wanted to know what kind of changes actually happen in the coir. So Overland sponsored this, and we had two different coir types here. We have coir type A and coir type B. They just have a very different history behind them. So you can see that we measure water holding capacity and air porosity, and they both change, but differently in different coir. So they both increase, but by different amounts in different coir types, which is logical. If you have a very poor coir quality, you get higher differences in porosity and water holding capacity, and you have this waterlogging problem that might happen if you have very poor quality. Again, if you look at chemical changes in coir, they were again substrate dependent, like pH in one of the coirs that we measured went up from virgin to the composted recycled stuff, and the other went down. The EC is a little bit all over the place. The potassium and calcium are changing depending on how you treat the coir and how old it is and all that. So it's not very simple to just say, oh, you need to do this. We need to do a bit more research into this. But when we looked at the crown rod pressure, it was quite obvious that directly reused bag, if we have about 60% of the times that we look in directly reused, we get crown rods out from a trial that was highly infected. And then in the composted, it was even worse. But when the proper recycling was done, that went back to zero. So at least recycling, we see that is reducing significantly biological pressure of crown rod. And this is here as well. So you see recycle have the same percent of crown rod symptoms, which is coming in from the infected plant material as the virgin. So what we've done this summer now is we actually went out on a limb a little bit, and we've done two quite large field trials where one at Niab and one at Kelsey Farm. And Kelsey Farm is quite large. So we have 18 tunnels full, each with 6 rows, 15 meters each, of different recycled coir types compared with virgin. And we're looking for crown rot assessment, we're looking for fruit yield and rots, we're looking at pests and weeds, and we're monitoring chemical and physical parameters to learn a little bit more about this. So this process has not been optimized yet for best recycled material. This is for us to learn what needs to be changed. And you'll see there's some things that still need improving. So first I'm going to go to the big one, the Kelsey trial. First, I have to say that the grower was extremely happy with this. Maybe he's on a call, maybe he isn't. You might be able to contact someone at Kelsey Farm. They grew Katrina. They had leg grow bags that were recycled. They were virgin and directly replanted. An unfortunate thing happened that when they were collecting yield data, they put the rows where they had the virgin and second year, so replanted bags, they put them together. So I can't really tell you anything more, but the yield of our recycled material was exactly the same, or maybe 1% better than combined yield of recycled and virgin. So we didn't see any differences in pests and weeds or crown rot, but it was not great in terms of assessment. So we're going to have to repeat this next year. But from seeing the trial every couple of weeks throughout the year, it looked better than the virgin, and it fruited earlier. So that's one of the take-home messages here. And then it comes to our semi-commercial trial with the Everbear Morlink Supreme that we done on site. Here we have a lot of data that we can talk about. It was a much smaller trial, so it's altogether over 1,200 plants rather than 60,000 pretty much. And we had two different coir types here. Here we have Allegro, the same as they had, virgin and recycled, and then we had Cocoa Green as well. And we're going to see that, and here it's not that these two bags were treated the same in the first year of growth. They were from different farms, from different management practices. Some, we don't even know, maybe they were used for more year than others. So it's not a brand, but it's a history of the coir that comes together with a brand that is affecting any differences that you will see. But the first take-home message from this trial is that we used 4% less water to reach the same coir moistures across the trial. So we saved some water. We expected this to happen because virgin coir is losing a lot of water in the first couple of weeks before plants take hold, while the recycled media has a better water holding capacity. And we had separate irrigation rigs, so we can give them separate amounts of water as they needed them. So the total yield in Cocoa Green, with its own history, it was all in all better history. So recycled had a little bit of a decline in total yield, but very little. While in the terms of the Allegro bags, the coir was used probably more that when we got them, and the recycling process did not take away all the yield penalties. So we had a slight decrease, which was statistically significant. In percent of class 1, it was the same for recycled and virgin. Recycled actually had slightly higher percent class 1 than virgin, but it was not statistically significant. Then a lot more graphs here. Class 1 yield, class 2 yield. It was no real striking differences in Cocoa Green again, but in Allegro, slightly less, almost significant, on borderline significant reduction in recycled in class 1 and in class 2. And then if you look at the berry weight of both classes, they did not change. So it looks like we had less berries, not smaller berries, or the size of the berries wasn't affected as much as likely. And then just to give you the same curve as you got for Kelsey, you can see very clearly the gray and the blue, both of these recycled, the gray and the blue are slightly under the yellow and orange throughout the time. So yellow and orange are both virgin, Cocoa Green and Allegro. So there is a slight across the season decline that we need to now learn more about, and we have taken lots of samples to learn about why that might be. So the next steps, what we're looking for improving the recycling process and mitigate chemical imbalances. So that's something that we can definitely do. And then we're testing inactivation of a wide range of pathogens rather than crown rot to see if some other pathogen might be responsible for this yield decline that is surviving our recycling. And then we're measuring pests and other pests and weeds as well. So arthropods, pests and weeds, to see if there's any problem there. We are trying to do wraparound agronomy. It's going to take a little bit of change. So the feed might be slightly different at the beginning than your feed at the beginning of the virgin coir, and it might be slightly different at the end as well, because it will be different profile, a chemical profile across the season developing. And we think that you might be able to reduce your water and fertilizer input because you get quite a lot of nutrients for the first week or so, first couple of weeks in your recycled media already. And then we're actually doing your economic and environmental assessment or analysis to compare the virgin and recycled from production to use in the tunnels to yield output, so you can then compare side by side with all the data that we're going to get from next year as well to see how effective this process is. So quick take-home message is that you can reuse bags in June bearer, but be prepared to suffer yield decline in ever bearer unless you have a very, very good bag quality that it might not affect ever bearer. Physical and chemical degradation of the coir in the bags is type dependent. Some coir might degrade more than other. And I think we can cost effectively recycle, but we still need to learn about this small yield decline that we're still seeing even with recycled. And we're looking at all the things that are happening on a microbiome scale, on chemical scale, on physical scale, and on fertigation optimization as well. So we're going to report that hopefully by next year when Overland might actually have a product for you already where you can buy recycled material. Or if you want to try now, we are happy to get you on a project as a farm, as a test farm, and you can put our coir in a corner somewhere to test it out yourself, as they did in Calcifarm. So acknowledge all the funders. That is started with the Interact project and co-funded by Berry Gardens, and now growing. This research is now supported by Growing Kent and Medway and Overland, and it's all done by Niab Pathology and other teams. So with that, I'm gonna overrun 2 minutes, and I apologize.
Thank you, Matt. A very, very, very quick question.
Yeah.
You mentioned composting, but in the recycled coir, composting is one part of that process. So what's the difference between composting and recycled? Well,
Scott, to be completely honest, composting happens on its own if you want it or not.
Yeah.
So when you store, so you have to take into account that your coir, the longer it stays in a pile, the more it's going to change due to composting. So we need to understand how long we can leave it in the pile, how the piles need to be turned and all that. That's something that Overland tried to understand a little bit more. And in the first year, we had some coir that was standing in the pile for probably for years that we used that was really bad quality. And we want to try to test something that is really bad quality to see what happens. And actually with surprisingly good results for the type that we used. It was like a powder. Coir was like almost like a powder, the Allegro type, which was standing for a very, very long time. So I'm positively surprised with that, to be completely honest.
Okay, we could talk about this for hours. Thank you so much for your time. So as Matt departs, I'll welcome our next speaker, who's Mark Else. Hopefully Mark is with us. Yes, we can see you, Mark. Perfect. If you'd like to share your presentation.
I think Phoebe's going to run through my slides, Scott.
Yeah, sorry. Yeah, Phoebe's got the presentation available. We'll just wait for the technology to work out here. Yeah, I should explain that Mark has some technology problems, and so we have to try and run his presentation for him in the background. So Mark is known to most of you. He heads up the crop science and production systems team at Niab at East Malling, and helps to run the wet centre, and has done a huge amount of work on water use efficiency. Mark, tell us a bit more about your latest work, and particularly on total controlled environment agriculture.
Excellent, thank you, Scott. Yes, and good morning, everyone. And so I just thought I'd spend 10 or 15 minutes talking about some of the work we've been doing over the last couple of years, looking at using vertical farming systems, or as we say here, total controlled environment agriculture systems, really to understand how we can optimize yield and quality in some of the Marling strawberry varieties. So if you go to the next slide, please, Phoebe. So the focus of the research in my department really is understanding how plants interact with the environment, and then how we can use that knowledge to improve fruit quality, consistency of yields, assure shelf life potential, and improve resource use efficiency and general production efficiency. So you'll see we tend to categorize those factors that impact on cropping potential in terms of genetics times environment times management. And as I said, our focus is on the environment side of things. And there are just sort of several aspects of the environment there in the spider diagram. And of course, all of these change continuously. And there are lots of interactions between those different factors as well. So how does this changing climate affect cropping potential? And how can we begin to tease out the relative contributions of G times E times M? So if you go to the next slide, please, Phoebe. So this is data collected from the wet centre over 2020, 2021 and 2022. So this was all with Marling Champion. So we're using the same genetics, and so we can account for that fact here by using the same variety. So they're planted in the same location, in the same, around about the same time, same planting density. So the management of those crops is fairly similar and consistent as well. And so Steve Kember's been visiting us regularly to make sure we keep on top of the agronomy and the management. So most of the variability here, I think we see in class 1 yields between the different years. Most of it is due perhaps to the environment rather than to the genetics or to differences in management style. Although obviously it's difficult to be absolutely certain in this case. But if you just focus on the blue bars there in each year, so the blue bars is class 1 yield per plant in the commercial area of the wet centre for those of you who've been to visit. And you'll see there then in 2020, we had an average of 1.25 kilograms of class 1 yield per plant, compared to just under a kilogram in 2021, and also just under a kilogram in 2022. So we've got the same variety grown in the same locations under very similar conditions in terms of management, yet we got this quite obvious difference in yield. And so those of us thinking back to 2020 in the UK, in the April and the May, of course, there were very high light intensity there. And we think that the high light intensity during those months then helped to support the high yields we see in 2020. But we also saw a difference in the very first flush. And so you can see this if we look into 2020 at week 28, we'll have about 550 grams of class 1 fruit. And if we look in week 28 in 2021, you'll see there we're down at 200 grams. And it was quite obvious in that year that the first flush in 2020, there were very few fruit compared to the first flush in 2020. So in 2020, we had primary fruit, 2 secondaries, 4 tertiaries, and probably 4 or 5 of 6 quaternaries. They were all class 1 fruit in 2020. 2021, we had obviously the primary, a couple of secondaries, and perhaps only 2 or 3 tertiaries made the class 1 grade. And so the real impact of the lower yields during the first flush in 2021 was due to fewer fruit number. And of course, those flowers would have been initiated in the previous year. So that gave us a clue really of the impact that perhaps plant quality in the environment during the propagation environment can have on cropping potential. And you'll see there obviously over time, as we begin to run into weeks 41 and 42, we run out of thermal time and we run out of light intensity. And so obviously the yield tends to drop off. Okay, next slide, please, Phoebe. And so we were interested to know, okay, well, how can we achieve the full cropping potential of some of these Marling varieties? And then, of course, the other question is, well, actually, what is the full cropping potential of some of these varieties? And so we decided to take some of the same batch of plants that we planted in the wet centre in 2021 and plant those in one of our new growth rooms. So if you go to the next slide, please, Phoebe. So as we've said, just under a kilogram of class 1 fruit in 2021. When we planted those same plants in the growth room, we planted them in May. They started to crop in August, and we continued cropping then until the following May, and then we terminated the experiment. So over those 9 months of cropping, the average plant yield, class 1 yield per plant, then was 2.5 kilograms compared to the kilogram or so of class 1 yield we had in 2021. So obviously we were able to maintain the thermal time and the light, and so that gave us a good indication of how we could extend cropping potential. But I think interestingly, again, one of the key observations we made in that work was that then, even though we provided what we thought were the optimum growing conditions, the class 1 yield per plant varied significantly in that experiment. And so the highest yielding plants were producing 3.2 kilograms of class 1 yield per plant, and the lowest then were only producing 1.6 kilograms of plant. So obviously quite a significant difference in cropping potential under what we thought were optimum conditions. So if you go to the next slide, please, Phoebe. And if we look at the relative position of those plants within the growth room, and you'll see there the map on the left is just individual plants, and you'll see the numbers in there are the yields, class 1 yields per plant. You'll see there's no obvious positional effect of on cropping potential. There's no the higher yields weren't achieved in plants near the aisle, and the lower yields weren't achieved in plants near the wall. So there seemed to be some variability in yield that wasn't explained by position. And so, of course, we're interested to understand what the cause of that. And I think going back to the data we saw in the wet centre in 2021, we were interested to understand then how the initial plant quality could later affect cropping potential. And if that was a problem, then what could we do in order to improve the quality of those rametes before we plant them out? So if you go on to the next slide, please. And so this is a new project now. We're just in Q2. It's a project led by Vertical Future, who are specialised in supplying R&D to support the TCEA industry in the UK. And so it's funded by Innovate UK. And the idea then is to try to understand how we could use these total control environment agriculture systems to try to maximise the quality of the strawberry propagules, so we can then assure cropping potential in each of the different production systems. So if you go on to the next slide, please. So as I mentioned, this project is led by Vertical Future. University of Reading are involved. So the University of Reading did some work on propagation, or have done some work in propagation over the last few years, especially in a PhD program that was funded by Berry Gardens. And so they have lots of expertise in understanding how to manipulate the environment to improve cropping potential. Cocoa Green providing the coir for the experiments, of course, Delta T, the precision sensing systems. And so we're working with Clockhouse Farm and their propagation company, Linton Growing, and also Hugh Low Farm and their propagation company, Blaze Plants, really to try and understand how we can improve the quality of those propagules and how then that improved quality affects yield potential in the different growing systems. And of course, Berry Gardens are also involved in the project. So the main aim of the project then in the first phase is to understand how we can optimize the growing environment during the propagation phase, so we can assure cropping potential. And so at the moment, Vertical Future are building 2 new TCEA containers, and you'll see a photograph there in the slide. So they will be delivered to East Marling in the new year. We'll have 1 container for production of mother plants, and then we'll have a second container then to plant out, strike out the tips, and to grow on the tray plants. And those both of those environments will be manipulated in order to try to improve the cropping potential of these plants. And so we'll then test them in traditional polytunnel production. We'll compare them with conventionally produced plants in glasshouse production, so controlled environment agriculture. And then we'll also compare them in a Vertical Future TCEA system as well. So the idea then of the project is to develop these high quality, high health propagules that we can then go on to use in those different growing systems to see whether we can try to achieve the full cropping potential of these varieties. Next slide, please. And so I think this is my final slide. So part of the work then is really trying to understand how we can optimize conditions under these TCEA systems, because of course we're in complete control of the environment. And so at the moment we're focusing on trying to understand how we can reduce inputs into those systems. The first piece of the work is using deficit irrigation. You'll see there a plant with a partially dried root system. So some of you will know we've been doing that sort of work for 20 years or so at East Marling, so we've got a very good understanding then of how we can apply deficit irrigation in a controlled way to reduce water use, but also to reduce transpirational water loss, of course, which will also then impact on humidity control. And so we've got the wireless balancers there in the photograph at the bottom left. That will tell us by how much we're reducing transpirational water loss by applying these deficit treatments. And of course, it's important that we still maintain fruit size and yield. And you'll see the photograph there of the strawberry with we have some LVDTs, and they measure fruit expansion continuously. And you'll see there the graph along the bottom then. That's just a trace of fruit expansion of a ripening strawberry from perhaps a small green stage on the left of the graph up to the ripening stage on the right of the graph. And just the picture there in the top right, so this was taken in October, and so both Marling Ace, and so the punnet on the left is Ace taken from the wet centre when we were beginning to run out of thermal time and light. And you can see there then the fruit on the right then was taken from our controlled environment room. And you can see the difference there. We were able to maintain those optimal conditions for far longer. So if you go on to the next slide, please, Phoebe. So just to say thank you to my team here at East Marling and to the farm team, to Steve Kember for his agronomic support, and also to Innovate UK, to Berry Gardens, to the East Marling Trust, and our current partners in this project. And so I'd welcome any questions if there are any. Thank you.
Thank you very much, Mark. No direct questions to you, I think, at this stage, but my question would be, and I don't know how easy this would be to answer, but looking ahead, if your new project is successful and identifies ways of providing more uniform, high-quality plants, how easy do you think it would be for commercial propagators or propagators, growers who are propagating for their own purposes, to actually apply the same sort of technology?
Yes, it's a good question, Scott. And so we're applying a sort of a variety of different treatments. Some of them will, necessitate changes in daily light integral or perhaps wavelength. Some will be more appropriate for traditional growing systems as well. So hopefully there'll be practical ways to help the conventional propagators to improve the quality of their propagules, but also then an opportunity to use vertical farming systems to produce these high health, high quality plants.
Good, thank you, Mark. I think that probably takes us up to time. Thank you for sharing that with you. I think it's an exciting project, and it, if it works and we get good results from it, could have quite a far-reaching repercussions for the industry and hopefully increasing our yields all round. Thank you, Mark.
Thank you.
So our final speaker of this session is Carlota Gonzalez-Noguer, who works with Mark as part of his Sea Crop Science Production Systems team at East Marling. As you will know from previous talks by Mark and Carlota, at the Wet Centre at East Marling, we aim to improve precision agriculture there, and we've improved the precision of our irrigation and fertigation over the years. It's an aspiration of ours that we would like to be able to supply the exact requirements of the plant as it needs it, when it needs it. And to this end, Carlota has been doing some work trying to match nitrogen supply to the demand in raspberry. She did give us a presentation on this last year, but I felt there was sufficient new information to share the results with you today. So good morning, Carlota.
Hi, thank you very much, Scott. Can you hear me and see the screen properly?
You perfectly, and see you and the screen. So thank you.
Great. Thank you very much for the introduction. So as Scott said, I'm going to be talking about the work we've been doing over the past 3 years to optimize fertilizer applications in raspberry. So first of all, just a bit of background of why this work is important. So as I'm sure you are all aware, fertilizer use and fertilizer applications in excess of what crops need is one of the main causes of climate change, one of the main contributions from the horticultural sector to climate change. And the reason for this is that when we supply too much nitrogen and that leaches into the soil, then it gets converted into nitrous oxide, which is about 300 times stronger than CO2 at trapping heat into the atmosphere. So reducing the use of fertilizers is one of the best ways to reduce our contribution to climate change. And optimizing fertilizer use is not only important from an environmental perspective, but also in terms of crop management. So if we use too much nitrogen, crops can have too much vegetative growth, which then complicates management. So it can increase picking costs because the fruit is more difficult to find. It can increase also disease persistence, and it can reduce light interception. So all in all, reducing the use of fertilizer is good for the environment, and it's good in terms of crop management. Another of the important parts of this is that fertilizer formulations were developed many, many years ago. They're quite outdated, and they are often just not variety specific. So we have a recipe for strawberries or for raspberries, and that's just one for all the varieties that we grow. And as well as that, we don't really change them throughout the season. So in the case of raspberries and strawberries, we would have a recipe for the vegetative phase, and then we will change it into the fruiting phase, but we don't really change them depending on how the crops are actually growing. So our objective with this work is to reduce fertilizer inputs by actually matching the nitrogen we supply to what the plants need. And how have we been doing this work? Well, we have been working to adapt an existing nutrition model called VegSys. So VegSys was developed in the south of Spain for tomatoes grown in the soil. And we've adapted it for different strawberries and raspberry varieties grown in coir. So I'm going to be focusing today on the work we've been doing on raspberry Molingbella. And the idea behind the model is that we can use environmental data. In the case of raspberry, we're using only temperature to then estimate crop growth and nutrient uptake. And then from that, we can make predictions of nitrogen requirements throughout the week. And also, because we are providing all our nutrition via fertigation, we also need to make predictions of how much water the plants are going to use, so that then we can adjust the concentration of nitrogen depending on water use as well. So we have been collecting data over the past 3 years in the wet center, and this was funded for the first 2 years between 2020 and 2022 by an Innovate UK project, SmartFert, which I talked about last year. So we had different industry partners for these projects. We've got the logos on the slide. And then this year just gone, the rest of the work has been funded by Niab. So in 2021, we started the work to collect data to calibrate the model. So we grew Molingbella plants in the wet center, and we grew them using a standard fertilizer recipe. So that was our commercial control. Throughout the season, we collected environmental data continuously with sensors, and then we also destructively harvested plants at 6 different time points. So what we did was we chopped the raspberries and we separated them into stems, leaves, and fruit. And then we quantified the dry weight of the different parts and also the nutrient composition. And we use this data to calibrate the model, which are these 2 graphs that you see on the right. And then in 2022, we had our first attempt to use the model to forecast nitrogen inputs in raspberry plants. So we grew, again, Molingbella plants in the wet center, and this time we had 2 different fertilizer treatments. So we had, again, a commercial control treatment with the standard fertilizer recipe. And then we had the treatment where we used the model to predict how much nitrogen the plants were going to use. So every 2 weeks, we updated the feed recipes depending on the environmental data. And we used evapotranspiration and crop coefficients to estimate water requirements. So we estimated as well how much water the plants were going to need, and then we adjusted the recipes accordingly. Throughout the season, again, we carried out different destructive harvests, and we measured yield, berry quality, bricks, etc. And what we found last year, so in the reduced nitrogen treatment, we had a huge reduction in nitrogen use. So about 63% less nitrogen was used and about 39% less water. However, we did see a decline in class 1 yields. So we had about 4.2 kilograms of class 1 fruit in the control versus 3.3 5 kilograms in the low nitrogen treatment. So the yield was still very high, but we did have a 16% decline, which was not what we wanted to see. And the reason for that decline was due to the fact that we had overestimated how much water the plants were going to use. So this graph here on the right, you can see in black is the line of how much water we were estimating the plants were going to use, and the red line actually indicates the water they were using. So this was due to inaccurate crop coefficients. We basically took crop coefficients from the literature and then used those to make our predictions. And that meant that we supplied less nitrogen that we actually wanted. So we had an impact on yield. So then 2023, we decided to repeat our validation of the end model with a slightly different approach. So again, this Caesar just gone, we've grown Molding Bell in the wet center under 2 different treatments. We had the commercial control again, and we had the nitrogen forecasted treatment. And this time, instead of using crop coefficients to predict the amount of water the plants were going to use, we use real data. So in the wet center, we have moisture sensors in the pots, but we also have water meters and rain gauges, so we can measure in real time how much water the plants are using. So what we've done this year is every 2 weeks, we've collected this data, we've looked at how much water the plants have used, and then we've adjusted the recipe depending on the water the plants have used in the previous 2 weeks, and depending on the environmental variables, so on the temperature. And again, we've measured yield, berry quality, bricks, etc. And the results from this year have been much, much better. So again, we've seen a huge reduction in nitrogen use. So about 76% less nitrogen in the nitrogen forecasted treatment, and about 27% less water. And this time, there was actually no significant differences in class 1 yield between the 2 treatments. Should say that there was about 6% less yield in the nitrogen forecasted compared to the control, but this difference was not statistically significant. So we had about 100 grams less of class 1 fruit per plant in the nitrogen treatment compared to the control. And this was due mainly to a slightly smaller berries. So in the control, we had 5.6 grams per berry, whereas in the nitrogen treatment, it was about 5.2. And as I said, the reduction in nitrogen use and in water use was huge. And the other observation we had, which is very, very promising, is that in the nitrogen forecasted treatment, the biomass of the plant, so the plant was much reduced. So this picture here is from the 23rd of October. And you can see on the left is our commercial control, and on the right is the nitrogen forecasted treatment. So the biomass in the nitrogen treatment was reduced from pretty much beginning of August. We didn't have to do any thinning on these plants. We didn't remove any leaves, whereas in the commercial controls, we did. We had to cut some of the canes and remove some of the leaves as well. And even then, by the end of the season, the control plants were still, as you can see here, were still pretty wild. So in terms, we didn't actually calculate what would be the savings in labor costs with the end model, but we didn't have to do any thinning. So I'm sure you'll know better than me how much does it cost to actually do these crop management tasks. So I've been talking about Molding Bella, but we have successfully implemented the end model in all the raspberries and strawberry varieties, and we've achieved different degrees of reduction in nitrogen, between 60 and 90% less nitrogen, and between 20 and 50% less water. But I should say that these reductions are very different between varieties, and they are not constant throughout the season. So the idea is that the model is dynamic, and that it changes the amount of nitrogen we put changes depending on the temperature and the climate that we're having at that particular moment. And then finally, just this is my last slide, some of the future work that we're hoping and planning to do. So we want to do some more work still to refine the model. So at the moment, we've been using temperature and water use data from the previous 2 weeks to then make changes in our fertilizer recipe. And the idea now, the next step is going to be to incorporate weather forecast and water use forecast into the model, so we can actually provide the right amount of nitrogen for the future rather than doing it retrospectively, which is what we're doing now. And that should improve as well the model. Another thing that we would like to look at is actually what is the availability of nutrients in the coir. So there's been quite a lot of work done in soil of how available the nutrients are for the plants, but there's not much in coir, let alone for different grades of coir or recycled coir, like Matt was explaining us. So this would be interesting to look at, because at the moment we're providing the plants exactly with the amount of nitrogen that they need. So if all this nitrogen is not available for them to take, then we need to know so that we can give them slightly more. And then the last thing, and we've got a new project starting in the next few months. We are going to be looking at the finishing to develop some inline sensors, so we can actually monitor nutrient delivery in real time, because as I'm sure you all know, with raspberries and strawberries, sometimes we slightly adjust the EC, and that means that we are changing the amount of nutrients we are providing. So if we can have sensors in the rig or in the irrigation lines, then we can, if we do these adjustments, we know what we are providing the plants, and we can change and feed the model and make adjustments to our recipes. And we've got some industry partners in this project as well. So just to finish, saying thank you very much to all the Niab Ismailing staff that has been involved in this project, and to the SmartFair Consortium as well. And I don't know if we've got time for any questions, but otherwise I've put my contact details there, and I'm happy for anyone to get in touch.
Thank you, Carlota. I think you've done a splendid job, because it's elicited several questions. We are moving into our break and we're slightly late. So what I'm going to propose is that, Carlota, if you can have a look at the questions in the chat box, and perhaps you can deal with them. There may be a little bit of overlap with some of them, but perhaps you can answer them, and other people can then see your response in the chat. Thank you so much, Carlota, and thanks for those questions. So that concludes session 1 of today's program.